Dear students, welcome to the ninth lecture of 8051 interrupts. So from this lecture we will start with the programming part of this chapter. So first as we all of know that there are two timer interrupts, two external interrupts and one serial port interrupts. So now we will take some examples with respect to timer interrupts. So hence I have written the title called timer interrupt programming. And one more note for you all is I will go in detail this program, and in similar ways we are writing the programs with respect to the interrupt programming, and hence I request all of you go through my lecture of this video very carefully so that the concept in order to write the next programs will be more easier. Okay, please take care of this problem and how I will flow this problem statement into the instructions, right? So let us start with the programming. So the question is, write a program that displays a value of y at port 0 and n at port 2, and also generates a square wave of 10 kilohertz with timer 0 in mode 2 at port pin P1.2, and we have to assume the crystal frequency that they have given is 22 megahertz. First try to get the question, then we will start with the programming instructions. So in the question what they are saying is, program that displays a value y on port 0. So we have a port 0 here. On this we need to display y, and we have a port P2, right? On this we need to display n, right? So this is the process that we need to do actually. So let us assume this is a main program, right? So while doing this process, in turn we need to generate the square wave. This is the main process. In turn we need to generate and also generates a square wave, and this square wave should have the frequency of 10 kilohertz. And in order to maintain this 10 kilohertz, we need to use timer 0 in mode 2, right? And this should be generated on which pin? Pin P1.2. So this is the main process, right? This is the main process, and this part I will call it by the name called since in the question they have given that we need to use timer 0 in mode 2, this is the main process, and this is the ISR. Which ISR? Timer 0 ISR I will call. Timer 0 ISR. So this is the problem statement. Please read the question once or twice, then the writing of the program will be very easy. Okay, so now let us start the programming. Okay, so for every interrupt programming we need to write these two instructions first. So first and foremost, as you know, our program starts with 0000H origin from 0000H. The next instruction is very much important while writing the interrupt programs is ljump main. ljump main, what it resembles is, we need to write this instruction because if I write this instruction, it will bypass the interrupt vector table. That means it will not go inside the interrupt vector table. Actually, the interrupt vector table starts with 0000H and ends with 0029H. You can refer the IVT table, right? You can refer the IVT table. Actually, we are bypassing this whole value, and hence the main program, uh, is to be started from 0030H actually. So in order to bypass this whole memory area, we are not going to enter inside because it is with respect to IVT. So we can't able to touch this particular area. Okay, the maximum value that IVT has taken is 0029H. From 0000H to 0029H, it is highly impossible to take this particular location because inside we have some interrupt addresses. Okay, hope you are clear about this statement. So in order to bypass this IVT, the main program has to be started with 0030H. In order to do so, we need to write ljump main. So after writing this particular statement, the comment that I have written is bypass IVT. Okay, ljump main. So where the main program starts actually now, the main program will start from org0030H. See, what I have written in the comment is location after IVT, because as I said, the location for IVT is 0000H, right? And it will end up to 0029H. What is the next location actually? 0030. From this we need to write the main program, right? In main program we need to write this, and in term we need to write the ISR. So how that is to be written? Hope this concept is clear now, right? Okay. First and foremost thing, as in case of timer, we have started the tmod. See, first we need to program the ISR, then we need to write the main program. So while writing the instructions with respect to the timers, right, first we need to give the information about tmod, right? In tmod, what will be there actually? We need to show the programmer or a controller that which timer is being used and in which mode we are, right? We are using timer 0 and mode 2. Put these two values inside tmod. Sure, you will get #02H. You can check it out later, right? So that information should be given to tmod H, right? So tmod H. Next, the square wave that we need to generate is of how many kilohertz? 10 kilohertz. And in which mode we need to generate that square wave? In mode 2, right? Already the information about T0 is given in tmod, but in mode 2, the mode 2 is with respect to auto reload, right? The mode 2 is with respect to auto reload. Then auto reload in sense we need to find the value of TH0. We need to find out the value of TH0 with respect to 10 kilohertz. Hope you know how we can calculate the value of TH0, right, for a 10 kilohertz, right? So for that I have already calculated here. Just I will show it by once again. They have given f is equal to 10 kilohertz, and they have given the crystal frequency 22 megahertz. Here they have given crystal frequency is equal to 22 megahertz, right? So f is equal to 10 kilohertz, crystal frequency is 22 megahertz, right? So first we need to calculate the value of the machine cycle for a 22 kilohertz. 1 by 12 of 22 megahertz is equal to 1.833. Take the inverse of that, you will get 0.5455, right? So T is equal to 1 by F. F is given 10 kilohertz, you will get 100 microseconds. If you, this is whole T, if I take only for one pulse, you will get 50 microseconds. Divided by this this value 0.5455, you will get 92, right? And if you subtract it from 256, because we are in mode 2, the maximum value it can take is 256 minus 92 is equal to 164 decimal value. If you convert that into a hexa value, we will get 0A4H, that is equal to TH0. So put that value here, move TH0 comma has 0A4H, count value inside the TH0. Next, the most important one in writing, the program for interrupt is. So here as before I said that while doing the main program there is an interrupt to generate the square wave, right? Which interrupt is generating now? Timer 0 interrupt is generating. So we need to initialize, we need to make one for that particular bit in IA register. How that is to be done? So before programming we need to initialize this particular timer 0 interrupt inside the program. That is to be done with the help of IE register, interrupt enable register. So here I have written the bit pattern of interrupt enable register for every interrupt programming part. Whichever the interrupts generated, that particular interrupt bit is to be put is equal to 1 in IE register before writing the code. That is compulsory, right? So here EA interrupt enable, this should be always equal to 1, because if this is equal to 1, whatever the bit value which is set to 1, that will be activated. Otherwise, if it is equal to 0, whatever the bit which you have set, that will be not activated. Here actually the timer 0 is interrupted, right? So for that particular bit I made that is equal to 1, external timer 0 interrupt. E stands for external timer 0 interrupt or enable timer 0, you can say. This is enable, not external, sorry. This is E stands for enable serial input, enable timer 1. EX stands for external interrupt 1. E stands for enable timer 0. EX stands for external 0, right? If now the case is timer 0, enable that timer 0 bit is equal to 1. So this is 1 0 0 0, that is 8. Next 0 0 1 0, that is 2. So AT2H, give this information to this particular IE value. So after TH value I have written the instruction code move IE hash AT2H, right? Enable interrupt timer 0, enable interrupt timer 0. Okay, next I will start the timer. Now I will start the timer. Okay, I will start the timer. The timer will be started. That means the square wave is generating now. Square wave is generating. Next what I will do, I will display the value of y directly to the port 0, that is move P0 comma hash 4, right? Next move P2 comma hash 9, right? Next S jump back. So from this back to this back, it is one of the main process that is going on, right? That is going on. This is the main process that is going on. So this process will be going on until and unless the value of TF of timer 0. See, please try to take my statement. The value of y is put into P0, the value of n is put into P2. This process will be continued until and unless the value of TF value becomes equal to 1. That is TF 0 becomes equal to 1. When the value of TF becomes equal to 1, the meaning is, so this process will be continued. This process will be continued until and unless the value of TH0 reaches to the maximum extent. The maximum value for TH0 is FFH. When TH value 0 reaches to FFH and when it resets back, the value of TF will becomes equal to 1 and it will come out of that particular and it will move to the ISR, right? So we need to write the ISR. So in ISR we need to generate this particular square wave. Where we need to generate the square wave? Actually on P1.2, just we need to complement this value. So in order to complement, so I have written ORG000BH. So ISR for timer 0 to generate the square wave. So ORG000BH. So this is the address which is given for timer 0 in IVT table, right? So there we are in ISR we are generating the square wave. So CPL space P1.2. So this process will be continued here. After the complementation, RETI will be get executed, return from the interrupt. So after return from the interrupt, it will go to the main program again. So this process will be continued until the value of TF value becomes equal to 1 again. Hope all of you are getting. So in the main program, when we will start with ORG with 30H, so move tmod, move th0, move IE, all these are initialization part, right? And set b tr0. Here we are going to start the timer programming, timer 0. When we start the timer 0, this process will be started actually. Y will be sent to P0, N will be sent to P2. This process will be continued until the value of TF value becomes equal to 1. The meaning is until TH value reaches to the maximum value, that is FFH, and when it resets back to 00H, TF value becomes equal to 1. When TF value becomes equal to 1, the meaning is the interrupt is generated. When the interrupt is generated, automatically from back it will come out of the ISR. From back it will come out of the ISR. So the first instruction there is ORG space 000BH. So there, what is the process that we are going to do in a ISR? We are generating the square wave, right, on P1.2, and hence I have written CPL space P1.2, right. After doing so, we are writing the return from the interrupt. After return from the interrupt, again back is to be taken and this process will be continued. Okay, so just go through this program once again. If you get any questions, you can put on to the comment, right? I will try to answer. Okay, thank you.